Hello everyone, welcome back, and today we are looking at question 876, which is the middle of a linked list. I love this question because it's easy to explain and also easy to implement, so let's get straight into it. So we are given the head of a singly linked list, and we just want to return the middle node of the linked list. The question says, if there are two middle nodes, we want to return the second middle node. So why they are saying this? Well, simply because if the linked list has an odd number of nodes, like example 1, we have 5 nodes, the linked list would only have one middle node, in this case 3. But as in example 2, if the linked list has an even number of nodes, the linked list would have 2 middle nodes, in this case 3 and 4. Okay, so in example 1, we would return 3. We see the output as 3, 4, 5 because when we return a pointer to 3, this is a linked list. The nodes are connected together. The output would be the node that we return and all the nodes connected to it. So when we return 3, the program itself would give you 3 and all the nodes connected to it, in this case 4 and 5. In example 2, we have 2 middle nodes because we have an even number of nodes. So the answer would be 4 because the question says we want to return the second middle node. And again, when you return 4, the program itself would just return all the nodes connected to 4, in this case 5 and 6. So let's go to the blackboard, explain the question, and come back here to code the solution out. Okay, I have made the same two examples, an odd number of nodes on top and a linked list with an even number of nodes at the bottom. Before I get into this, I just want you to imagine yourself on a straight line and you are here with your friend and you want to race, okay? But there's a catch. You are 2 times faster than your friend. So let me ask you a question. Let's say this is the 50 mark and this is the 100 mark. If you are 2 times faster than your friend, by the time that you reach 100, your friend would have been only at 50, right? Since you are 2 times faster, you would finish in half the time. So when you reach 100, your slow friend would only reach 50. We would solve the question using the same exact idea, okay? So starting with example 1, with the linked list that has odd number of nodes, we would have 2 pointers, a slow pointer pointing to the head, and a fast pointer also pointing at the head. This is you and your slow friend starting at the head. Now, we said that you run 2 times faster than your friend, so we will move the fast pointer 2 nodes at a time, and the slow pointer would move only 1 node at a time. Okay, so now, the fast pointer would move from 1 to 3, and now the slow pointer would move from 1 to 2, okay? Now the fast pointer would move from 3 to 5, and now the slow pointer would move from 2 to 3. Notice that now the fast pointer has reached the tail of the linked list. How we know this is the tail? Because the tail.next would equal null, and 5.next is null, so the fast pointer has reached the tail, which is the end of the linked list. So when the fast reached the end, we notice that the slow pointer is pointing to the middle node. Okay, let's look at example 2. We know that since we have an even number of nodes, we have 2 middle nodes, in this case 3 and 4. So let's see how this strategy works down there. Again, we have the slow pointer and we have the fast pointer at the end. At the start, the fast pointer would go from 1 to 3. Here we are. And the slow pointer would move from 1 to 2. Now, the fast pointer would move from 3 to 5, indicating 2 steps at a time, and the slow pointer would move from 2 to 3. Again, the fast pointer would move 2 steps ahead, so it would go from 5 to 6, then from 6 to null. And now, the slow pointer would move from 3 to 4. We notice that the fast pointer has reached null, okay, which means reached the end. And at this point, we notice that the slow pointer is pointing to the second middle of the linked list. Again, we have 2 middle nodes here, 3 and 4, but 4 is the second middle, so the slow is pointing to the right node. Okay, so I want you to focus on this. In this case, fast.next equals null, and in the other case, the fast itself is equals to null. These would be the condition in the while loop that we will use. So let's go to LeetCode and code the solution out. Okay, here we are. We said we need 2 pointers, a slow pointer and a fast pointer. So list node slow and the slow would start at the head. And now we need the fast pointer, so list node fast, and this would also start at the head. And now we have a while loop, and we said that we will keep moving until fast does not equal null and fast.next does not equal null. We said until fast.next does not equal null and fast does not equal null, because in either of these cases we have reached the end of the linked list. Okay, so now we need to advance slow, and we said slow only moves one step at a time, so slow equals slow.next. And we said that fast moves 2 nodes at a time, so fast equals fast.next.next. And that's it. When this while loop breaks, fast would have reached the end of the linked list, and slow would have been pointing to the correct middle node. Return slow. So let's run the code and let's submit. Here we go, faster than 100%. Okay, so now let's look at the time and space complexity. Okay, we used 2 pointers and we did not use anything else, so the space is constant, so the space complexity is big O of 1. Now in terms of the time complexity, we use the while loop and we moved through the nodes of the linked list. Assuming we have n nodes in the linked list, the time complexity would be big O of n. I hope you guys enjoyed the video. Best of luck to you and see you in the next one.